few minutes. Here's the first.
Yeah.
Yeah. We should probably get going just to reward the ones who signed up on time to create the incentive to arrive late. If you know it will start 3 to 5 minutes late, then just keep arriving late. That's very loud.
Good morning, everybody. Welcome to second Rtgwg meeting, and we're going to start with keychain young model.
One more minute. Let's see. Yeah.
Good morning, everyone. My name is Rtgwg from Cisco. I'm here today to present an update of the keychain young data model. So what has changed since last time? One comment we got from last time was to consider an explicit code point for now empty authentication. It covers the case where the authentication field in the protocol need to be used, but the mechanism for providing an authentication is not in use. BFD has a special use of this case. It adds an explicit authentication code point without authentication. So it can simply take advantage of the sequencing number in the authentication field. So we added this support of this now or empty authentication. Another change we did was to change our module name back to IETF keychain instead of IETF routing keychain. So for this new now empty authentication algorithm, we defined it as a feature in case not all implementations support it. This slide shows all the crypto algorithm currently defined by this model. It can be easily augmented if new crypto algorithm need to be added later. So what's the current status of this keychain data model? It defines a globally list of keychains. Each keychain has a list of keys. Each key has its own send, accept, lifetime, crypto algorithm, and a key. So far, this keychain model has been used by ISS, OSPF, and BFD, and we sure hope there are more to follow. What's the next steps? Currently, the model is written following the open config upper state proposal, and we will do another update based on the upper state requirement that we hope to reach at this IETF. Functionality-wise, this model is complete, and we are ready for last call. So that's it. Any question? It's a simple update.
Thank you. Very good work. So this model has been adopted by IGPs, by PSAP. There's more. Looks really good. So is it in request to start working group last call? Thank you.
Thank you.
Lou, Chris.
Hi, Lou Berger for the routing area Yang design team. This slides were actually put together by Chris. Chris didn't have the opportunity to present for the design team. He really wanted to, but he actually feels a little under the weather, so he asked me to do this. So hopefully I know what's on his slides. I may not, so if you have questions, please jump in. There's one important topic I think he has in here related to the comment at the end of the last presentation about what to do with operational state. So we want to make sure to talk about that. I hope it's in the slides, but we'll find out.
Lou, and you've got all the time. Please go in details.
Okay. Okay, so where are we from the last meeting? The first thing is that at the last meeting we talked about the three documents, two that are our standards track, one that's more informational, and that we wanted to move those towards adoption in the working group. Obviously, we have draft IETF on the logical network element and the network instance, so we were successful on those two. On the third document, we had some issues with IPR responses, and it really had to do with, and this is the device model document. Some of it had to do with the history of the document and how we constructed it, the design team. What we did is we actually started with the original OpenConfig document, and we stole a lot of text from there. And because we stole a lot of text from there in the first version, we said, everyone who wrote that original one, we think of as contributors. And then we did a whole lot of modifications and really diverged from where they started. And we still left them as contributors, and they're not responding to the IPR poll because they really had nothing to do with the document. So, you know, them not responding is sort of fair because they didn't work on it, we did. And we took their words, so even though we view them as contributors, they don't necessarily view themselves that way. So we're gonna move them from contributors to the acknowledgement. I think it's appropriate given the history of the document. I think it's also important for the working group to know what's going on, is that there's not like a bait and switch thing happening for IPR reasons. So we want to be fully transparent in our change there. I wanted to have that done on Monday. I apologize that I didn't get time to put it out. I still hope to get that change done this week.
So going forward, please, if you are on the draft, respond. I sent 3 times private emails and no response, so it really stalls the documents. So the last document had been in limbo for 7 weeks. It shouldn't be the case.
And it also goes to when to not put someone as an author or a contributor in a document. And, you know, I'll say I did bad here, we did bad here as a design team. We've talked in the past that you shouldn't just put someone on as author because you think they are. They have to agree that they are. So anyway. So our fault on that one. What are the main activities of the design team going forward? So we've dealt with the first set of big problems. That set of big problems has resulted in the creation of the thing called schema mount, which is the enabler for our two standards track document, LNE and NI. That's great. We've done that. We've helped push along the operational state discussion. That's great. That's passed. Now what's forward? The first is conventions. We've talked a bit about what conventions would be appropriate for the routing area. Frankly, this has been a lower priority than those other 2 big items. And rightly so, but it's still an important discussion. And we would like to spend more time on it. It would have been good for Chris to talk to this because he's the one who has the most opinions on it. So Chris comes from a vendor background, now at an operator, and he's doing a lot of work in this area. So he has a lot of good firsthand knowledge. I have less of it, so he's the right person to talk to it. I'm not sure what he was thinking on the next bullet, but if there's a whole bunch of, if there is a question of coordination, I think it's really for this working group to address. And if we as a design team can help, we're happy to. But from my standpoint, it's more of a working group thing than just a design team thing. So it's a bigger problem than just the design team. But if there's room for us as the design team to help, it would be good to, we're here. So I'm not sure if he's thinking about more than that, but that's my feeling on it. If the chairs or the AD want to elaborate, correct me, redirect the design team, that's also fine.
Oh yeah, well, I certainly don't want to try and redirect the design team here, but I think you're doing a really good job, and I really appreciate it. It's a lot of work, and I know that. Just for the track assist, one of the types of questions around this are, what's the set of models that we actually need for it to be useful for managing a router? Do they work together? What stage are they all at? How do they connect up? Those types of things where a working group tends to focus on what people focus on, what interests them, and you don't necessarily get somebody or a small group of people who have a coherent view and can make sure that things actually connect up. That's the type of thing.
Okay. So I'll speak for my own personal view on this. I can't, the design team hasn't had the discussion, so I can't speak for them. My own personal view is having a sort of a profile, or as Andy Bierman would say, a package that describes what you would expect on a particular type or class of network device, I think would be extremely useful. And I think that would be a very appropriate thing for the working group to say, if you are a router that does these kinds of capabilities, here are the Yang models you should support. And whether that be an informational document, standards track document, something that goes in catalog, something that goes in a package, don't know. But I think that would be really a very useful thing to have. I guess we can bring that in as a design team deliverable. It doesn't have to be.
Would be great.
What's that? Okay.
I think that would be useful. That a couple IETFs ago, there was a little bit of that work for VCPE, right? That came to NetMod, I believe.
I didn't hear the.
Sorry, there was a couple IETFs ago, there was a draft that was trying to do a little bit of that for VCPE. And I thought that was useful and interesting because it helped highlight the difference in expectations and models that were needed for different roles in the network.
Yeah, I did see there has been, in NetMod, there was a document that talked about how would you structure such a package. There was that document, and I seem to remember there was one document that talked about it for, you know what, I can't remember. Was it wireless devices? There was one. I don't know whatever happened to that. I don't know if the authors thought there was an interest in it and sort of went away, but maybe we should dig it up and encourage the authors to bring their document back.
I think we should certainly encourage them. It may also be useful to have the design team sort of do a first pass of one to think through. Basically, if you have a template of this is the kind of stuff to think about for a router in a particular role, it may make it easier for other people to create ones and make sure they're not missing pieces. We could talk about this offline. I know you have a lot more to talk about.
I was looking at a time check because I realized I didn't notice what time I came up. I have another 10 minutes or?
More than that.
Okay. All right. So the next possible classification, we're going to talk a little bit more about that, I believe, in the slides. But basically, there's a notion of taking the device model, which we had originally wanted to do as a sort of a more rigid tree, and we got pushback on that rigid isn't good, and you know what, the pushback is probably right. So we have an alternate mechanism we're thinking about in order to deal with our classification and do it in a more flexible way, and I'll talk about that in a little bit. But we think that this is the next piece of technical work we're going to be taking on. So how to develop faster? Yeah, that's a great topic. We keep asking about that. I wish I knew what Chris was going to say on this. And I believe we're gonna talk about op state guidance also in slides. If we're not, I'll certainly talk about that at the end. And the other question is what about other types of operational information? I'm avoiding the word state, such as counters. What happens with those? And we'll talk about that also. So we do have a little bit more on conventions. So what type of conventions might the design team help consolidate for the routing area? Common things like router ID, I think that's actually taken care of in now the base config routing document. AC, is that correct? Router ID you take care of, right? All right, so that'll come off our list because it's going into that document.
Actually, it's in there as a feature.
Okay, so I can repeat for AC. AC says that it's a feature that can be used globally inside the routing config Yang model, which has been being wrapped up in netmod. Another thing is, and this really is a convention, what do we call common names? I mean, do we think, like if we have multiple policies, is that under dash policy or is it policies? And, you know, maybe it's good if we have some conventions of, when we come across the same term to name it the same way, whether it be singular, plural, or different flavor. We think that would be a useful thing, just so we, when you go from model to model in our area, that it feels like you're dealing with a consistent thing rather than some haphazard arrangement of I don't know. Anyway, a haphazard arrangement of naming. And then are there other common constructs, groupings, features, containers that we can then might reuse? Don't know. That's things to think about. And of course, across the board, we want to be identifying elements that are being commonly defined in multiple models in our area and figure out whether or not there's a way we can have some reuse rather than redefinition. I actually mentioned this before. What we are doing is heavily relies on some solutions that we expect to come out of the netmod working group. First is schema mount, and this is our solution to logical routers or virtual routers, as well as network instances, which are VRFs. And then, of course, op state. And by this, excuse me, we're really referring to the distinction of applied configuration versus intended configuration. And if Sue was here, she would jump up and say, also ephemeral. Sue? Well, I'll speak for Sue, and also ephemeral. So this is one of the topics I said we'd talk about later. Classification. So what are we thinking about here? On the left-hand side, we have a device hierarchy that we had at one point talked about being required in XPath. So required in the sort of the naming hierarchy. We got a lot of pushback saying that that's not good to make everyone come and register and fit into one unified model. It's going to be particularly hard, particularly when you think about all the groups inside the IETF. Oh, but wait, there's other SDOs who might come in and want to fit into the hierarchy. This really isn't a good idea. And we agreed reluctantly, but it turns out that pushback was right. So what do we do to give us still the same value of being able to understand how models fit together? What kind of solution do we have for that? So we have a document that we brought in as informational that our expectation was going to be, well, that's just for people to think about. And we said, can we do something better than just enabling people to think about it? Particularly as moving forward, as we move, as the technology matures, it's likely that new people will come around and they may miss this document and they won't know to think about models in a particular structure. What do we do about that? And we've come up with the idea of building on the classification work that's going in NetMod, so that we can start, rather than put in a strict hierarchy in all our models, we can take our models and tag them. And Chris gave you the analogy of the hashtag. I really like that. I was thinking of just classifiers, but whatever. So, you think about it as a hashtag. When we come up with a new model, we say, okay, this is a control plane protocol, and it's a routing protocol. So we can do multiple tags. We don't have to just choose one. Or it's a control plane protocol, and it's a path setup protocol. And we might have standard ones, which are managed by IANA, and we also might have non-standard ones that are managed by vendors, other organizations, even OpenConfig, or even by the operator themselves. Let's say an operator wants to, by the way, this might not just apply to network devices, it also could apply to management systems that are themselves exposing Yang models. And they want to construct models in a particular way that's a little novel, a little meaningful to them. They might add their own tags, just like operators can define their own SRLGs. So that's the basic concept. We're going to build on the classifier approach. And then we have to also decide, where do these tags live? One place they could live is in a off-device catalog. So that may be a place, might be a service available from a standards organization, like we publish all the ones, all the tags that have gone through IANA. It might be on an internal server inside a provider that has how they want to lay things out, or it might even be on the device using something like library, so that when you look through, when you go to the device, you can say, hey, give me all your control plane models that you support. So you could basically query and then learn what's on the device. Of course, it's going to be really important not to have to touch the device in order to find out what is on a device before it's installed. So this is where that idea of packages might come in, where you might have an idea that if you're a router of this class, you're going to have those models. So there's times that it'll be useful, times that it won't.
AC Lindum, design team. One thing is, Yang has gone from having absolutely no place to put these to having multiple choices just in the last year. We have the metadata and we have these catalogs and things, the Yang library. So it's not really obvious exactly where it should go right now.
Yeah, and this is part of the work, is to figure out where that should go. Another part of the work is who should define these and how to manage them. We could go and, for existing models, go back and say, yeah, these tags apply, but it's really the people writing models that should be thinking about it, even if it doesn't go in the model, to say it is of this type, this class. By the way, when I've said that before to some of the folks in NetMod who are working on Yang, they say, wait, you're wrong, because the model may be a device model in this case and a service model in that case, so you don't want the model developer to define it. I think there's room for both. It gets interesting. That is, if you're interested in this topic. If you're not interested in the topic, I'm sorry, I know I'm boring you.
I just had a quick question from a sort of, somewhat naive point of view. These tags, are they just completely ignored by the Yang validator?
We're making this up as we're going along.
But is that the general idea, or I'm just trying to understand?
So there is something called the classification. The original notion was put it in description. So since it's in description, it completely gets ignored. But of course, that also gets ignored by tooling that wants to use it. So that's not where it's going to show up. So the next step in the evolution is, let's put it in the catalog and have an element in the catalog which basically has an enum. And that's where the document stands right now. And we're saying, no, let's go beyond enum. So it's an evolving thing. So if it's an enum, that gets validated pretty straightforward way. But we think that that's too restrictive.
I would say runtime validation would be useful. Otherwise, you could use pretty much anything. It wouldn't be resolved and break your model.
Yeah. So this is evolving work. Okay. I'm not sure how many other slides. I want to wrap up because I know I'm going over time. I want to wrap up with the op state discussion. So let's see if we can find a slide on that.
Brief comment on the catalog stuff Jeff has. So the property I think you're looking for, it's okay for it to be sort of free form. You know, if we can actually manage a good syntax that the language is happy with, because what you'd want to be able to do is go to a device and basically say, give me all of the, you know, for example, control plane protocols, get the slice of that, and that'll give you all the mount points for the various things. There may be cases where vendors want to actually tag things in a specific way, potentially for local purposes. You know, for example, this is a control plane protocol that supports vendor-specific feature.
Yeah, absolutely, absolutely. And we see that there should be some standard terms, probably IAM managed, as well as some free-form things that maybe, as I said, vendor managed or even user managed. And it's a union. It's not alternates. Exactly. Next. So we're gonna.
Lou, you've got 20 minutes, so you don't have to run again.
Oh, I have 20 minutes?
Yeah. So
I thought I had 20 minutes total. Okay.
30. So explain what you can explain.
Okay. So, oh, well, it turns out Chris had made a slide on what I just talked about. So, next. Oh, cool. Remember I said I wanted to know what he was thinking about developing faster? We get to learn what he was thinking here. So one of the interesting things is that Benoit, the area director for the ops area director who looks over the NetMod working group, has stood up inside NetMod as well as to the routing area chairs and said we have to be done in 12 months. We have to have RFCs in 12 months. And whether intentionally or unintentionally, he hasn't told us what has to be done in 12 months. It's nice to have deadlines. It's important to have deadlines. From my standpoint, I look at it as we have to have some core pieces done within 12 months. So one of the other hats I wear is NetMod co-chair. So I look at it and I hear that 12 months and I say, boy, we better have some core pieces done in that time frame. So I would think that the base routing config document should be done in 12 months. Hey, guess what? I think it actually should be done by through last call before the next meeting. Then there's schema mount. Well, I think before the next meeting, we should have the technical solution agreed to. And then if we have that agreed to, we can polish it and have it published within 12 months. Op state, and this is for the applied versus intended config, I sort of feel the same thing, is we have to have enough of a agreement on a solution to have that published to the working group as a working group document before the next meeting in order to have a chance for 12 months. In terms of the routing area, that's for this group to decide what things are critical that are important to be done in 12 months. Will everything be done in 12 months? Will we be able to publish our documents and go home, not come back to the IETF? Well, that hasn't worked so far, so I don't expect it to work going forward either. We will continue to have evolving work in the IETF or in any organization. In other words, the technology isn't going to die. So what things need to be done by 12 months and what's important? I think the group should really think about what are the key components and blocking items for the area and focus on getting those to at least into the ISG in 12 months.
AC Linda, one thing I think we should think about is the relatively size of these models, because the
Can you lean in a little? I don't know about anyone else.
One thing I think we think about is kind of putting a cap right now and doing the rest through augmentations for the core protocols. Is already the size is pretty unwieldy for the BGP, OSPF, and ISIS models. I don't really know how big the model is, but I know the drafts are approaching, exceeding 100 pages. So it almost seems like we should look at, okay, is this a good base? Is there things do we have the right set of things that constitutes the basis of the protocol and go forward with them and do the rest in augmentation? Just because they are so big, right, to be intellectually consumable, get people to look at them and review them.
Jeff, so the right answer for protocol modules is going to be it's the right size. And what that's going to mean is partially going to depend on what you consider the features that need to go in the thing. The comment was made in another working group session was that actually it was the working group chair's training for routing. We're better off putting more stuff into a base model, for stable known features than like the core of a given protocol. So an example would be, BGP is just RFC 4271. IPv4 unicast, nobody ships that as the base implementation, is anymore. Even the free software, has a lot more of the base features. But to allow for the cases where people don't support everything, you can do some level of throw it all into the model. You can use a feature to make sure that people are conformant if they don't happen to support a given item. And it actually has the benefit that makes sure that you have all of the keying, all the indexing set up properly for all of these features as they relate to each other. Whereas if you try to sort of prematurely trim it down to the barest possible, there may be a tendency to put in something that is very hard to extend at a later point in time. It's trivial to add augmentations to good structure, but it is very hard to add structure without a complete rewrite of the module.
Yeah, actually, that's getting at something I'm going to talk about a little bit later, where it's very important to get the structure right. But once you have the structure right, it's less important to publish everything in the same document. And it's good to think about the whole problem, but then perhaps, and this is again a personal recommendation, perhaps publish our models to align with how we've published our base documents. So rather than have something which maps to 5 RFCs, have the structure mapped to 5 RFCs, but then do 5 separate, one base model and then 4 augmentations.
Right, and a bit of comment that had been given when we were in the process of asking Chin Company to take, help us manage where our models were, was that we're actually better off just putting together a very large model at some point and then refactoring later. Premature refactoring is what causes us problems. If we're at the point where we think we're mature in something and your desire is to trim it down, there's nothing stopping somebody from doing the experiment of actually doing that refactoring and see how that impacts module maintenance, because maintenance is what becomes difficult once you do refactoring.
Right. Notice I didn't use the word refactor, because to me, refactor usually involves reorganization of the models as opposed to partitioning for standards purposes. So I actually intentionally didn't use the word refactor. I don't think we should refactor. I think maybe we should leave room for those extensions that we defined separately in a separate extension document, but push the base out, get the base moving so that it can be standard at a faster pace.
And the final comment is when we try to have part of this conversation, when OpenConfig originally brought in their module to BGP,
lean in to the mic a little bit more.
The comment that had been given to the OpenConfig guys when they brought BGP into IDR was, okay, so if we're going to do these things for features, what's the core of the protocol? There was resounding silence from IDR.
Yeah, I think that's actually another point, one I wasn't making, but also very important. Whenever we want, conformance has to mean something, so there has to be a base required set.
So Atlas, on the timeliness, one of the things is a combination of getting these good enough. We can't, if we strive for perfection, you end up in the long tail of taking too long. I know you know this.
No,
and
I'm nodding my head in agreement.
Yes,
Yeah.
and the second one tying to this is having base models that have 80%, 60%, whatever core functionalities, not trying to dot all the I's, cross the T's. We've got to get a good enough set out for experimentation, and it's okay if we end up coming back and needing, based on experience, Yang evolution, to do additional work in a few years. The second one is it would be nice to have and be playing with, and some of the running code of how these models are actually connecting actual implementations and seeing how they work as a moving pieces as opposed to a static document.
Yeah, absolutely. And if the thing that you're talking about waiting forever for perfection, yeah, that's really bad. I completely agree. We can rev things. And if it's a particular feature or a particular extension or aspect of a protocol that's slowing us down, use the great tools that Yang provides, like augmentation. So you don't have to have everything in one document. Publish the document and then come and get that extension, that extra feature and an augmentation to the base model.
Right, and the augmentations and how to use them may be part of some of the conventions, because as we continue to add even more extensions to OSPF, ISIS, and BGP, considering how we're going to augment the associated Yang models at the same time is an important factor.
Yeah, and I think that goes back to Jeff's point about getting the base structure right. He's absolutely right. You do have to think about things and make sure your structure is good to allow the augmentation. And if you get it wrong, you're screwed. But then, you know what? So it's not a big deal. You come back and rev the base model.
So Chris Bowers, you mentioned a moment ago having the Yang model structure of documents mirror the structure of the RFCs that went into the protocol in the first place.
Yeah, personal statement, not
Okay.
discussed.
Yeah,
It's just
okay.
it's like something to think about.
Right. I think that's a very bad idea. I think the fact that we need to look at 10 different documents to figure out how to write an OSPF implementation is sort of a drawback. It's an historical artifact, and by default, you should definitely not be doing that. As a tool to get around certain blocking points in moving say a Yang model for OSPF forward, great, do that. But I think Jeff mentioned there are, a base implementation is a lot more than the first protocol draft at this point. And I would accept that as what the base implementation is. And
Right.
it depends on each case, but
if you choose to make your base model on support the first 10 RFCs on a topic, that's completely reasonable. But then you don't have to support all 50.
Sure.
And so I agree. Make your base smart, but choose wisely. But don't wait to get everything. Do the first 10, not the first 50. And maybe when we take OSPF or whatever, BGP, or take your favorite protocol, I have mine, of course, to full standard, combine those documents.
Lou, I have a request. So we know guidelines for Benoit. On the other side, we've got number of reasonably stable drafts which have upstate integrated, so open config way. What is routing area guideline for those? Refactoring, keeping as is?
Next slide, I think. So if I understood the question, can we go to the next slide? Yeah. So if I'm not mistaken, the question was, what do we do about applied and intended and document and models that have been refactored to take the convention-based approach to solving applied? Is that correct? Did I understand the question correctly? Okay, good. So this is I don't know what else is in his slides, but this is the last topic, and I think an important topic that I'm going to cover. So over in NetMod, there's been discussions on what to do about how to solve applied versus intended configuration. So what is intended? Intended is what the management station, management user has told the device, this is what I want your configuration to look like. And we know, particularly in larger systems, it takes a little while for that configuration to be applied to the system, to actually be running. And we want to be able to represent that difference in our models. So we want to understand what our intended configuration is, and then what is actually running, what is actually applied in the system. That's the base distinction. There's a lot of subtlety to it, there's the folks at OpenConfig proposed a solution to the problem. Well, first of all, they're the ones who brought in the discussion related to standardizing a solution at all. So that was a big step. And they have a proposed solution which is being implemented in their models, which is a convention-based approach, that you add something to your path that says, this is what our intended config is, and this is what our applied config is, and you go read the leaves appropriately and you get the state. The problem with that is and some of you have experienced this, is you have to refactor all your models to go from what you think of as normal configuration and then add a whole bunch of extra leaves to deal with this extra state. And then if, oh, by the way, we want to do ephemeral, we got to add more leaves. It's a little cumbersome. My personal hope was that we could get a tools-based approach to solve the problem, that we wouldn't have to make a more fundamental change. But when we look through the tools-based approaches, they also had problems. So the options came down to, do we impose, to solve this particular problem, do we impose a convention that has to be followed by every model written today and every model written by the future, oh, and by the way, by every SDO and every organization? Do we do that? Or do we do something in the language, in the infrastructure to support it? And when talking inside the ops area, the answer was, let's do something in the protocols, in the language, so that not every model writer has to think about it. So the direction out of NetMod and the consensus out of NetMod is, do not refactor your models to indicate applied versus intended configuration. Do not do that. There's going to be a revised data store model. And by the way, it's a conceptual model. This isn't saying that you have to build more data stores on your hardware. It can be completely conceptual. There'll be a revised data store model that's probably accessible through changes in RESTconf and NetConf or whatever protocol you're using to access your Yang models, to support these different states of the data. So define what makes sense from a configuration hierarchy standpoint, and then use the tooling, although it's the protocol level tooling, to give you the different types of information, whether it's intended or applied, ephemeral, what comes down the pipe tomorrow. The guidance is basically, don't, not must not, should not, refactor your models. If your models to follow the convention of applied versus intended. So don't add leaves that say applied config. And it also is a little bit stronger than that, is not only don't refactor, is it's better for your models not to have those. But the reality is that since while this discussion has been taking place, a whole bunch of people have refactored their models, and the working group really wants to follow that way. So what do you do? And NetMod has a decision of what NetMod's going to do. That doesn't affect other working groups. The Ops AD has said you should follow this direction. But he also has said, and in discussion with our AD, has said it's not a requirement. So for example, the BGP model doesn't have to be refactored to remove the applied leaves or branches. According to the direction, it should be, but it doesn't have to be. So there's a subtlety there. We allow for working group consensus. I personally think it's not a great idea to leave those leaves around. And but I also recognize the importance of not resetting work and publishing documents. We were just talking about getting things done quickly. Trade-off there. It's got to be made with there's got to be an informed decision made by the model writers, by the working group chairs, and the area director. And the message from ops is it's your call. Now, what do we think as a design team? First of all, we haven't come out with a recommendation as the design team. I can tell you where we're thinking. Our thinking is we'll recognize that the direction is you shouldn't have the convention-based solution in your models. So it's a should not. It's okay if you do, but if you do, and this is the part we're thinking about and really want to hear feedback on, if you do it as an augmentation. And since it's an augmentation, that means today you run the augmentation, but down the road, when the other solution is actually available, you don't have to run that augmentation, or you run both. And someone new coming along doesn't run the augmentation. So that's what we're thinking. We have to have more discussion internally before we come back. Since this is such a fast-moving area and we don't want to be the gating item, we don't want to say we're going to come back in 3 months. We're giving some information of where we're going, and we would love to hear from model writers, from working groups, what they think. So if you have an opinion on this and I haven't put you all to sleep, it would be really good to hear from you. I think I've talked too long because I'm not getting any answers.
You still have.
But on the prior one, go back, please. So does anyone have any comments on this? How many of you have Yang models? Okay, there's a few people in here. How many of you have refactored your models already to support applied config using convention, the convention-based approach, the open config approach? I don't know, half that number. How many of you want to change back and get rid of that complexity? A couple of people. How many? So that leaves there's a few people who don't, right? So there's a number of people who didn't raise their hand. So there's a few of you who should raise your hand and say you don't want to make a change. You want to keep the convention-based approach, right? There are a few of you. Any hands? I see a couple. So how would you guys feel about using an augmentation to support that?
Yeah, I would just say stop changing the rules. Stop changing the rules.
Stop changing the rules. In other words, let us publish.
Yeah, stick with something that we think makes sense.
Okay, we agree. So of those the 2 or 3 of you who said you don't want to refactor again, which I understand, would you be okay with an augmentation? Okay. Anyone think that it's a bad idea to do an augmentation? That's very useful feedback. Thank you. So no one thought it was a bad idea to take the augmentation approach. So that's really good information. I should say we haven't talked to the Yang doctors about this idea yet, so we got to talk to them. They may say you're being stupid because we're just users, and that may be true.
So it looks like we come up with, it's not a recommendation, React Cluster recommendation. Even if you keep upstate integrated, please do go to augmentation. Don't keep them asleep, right?
You know what? The acoustics in here are kind of tough where I'm standing, so I couldn't hear you.
I just repeat what you said. So.
Oh, okay. Thank you. All right. This is a minor point. Whether you use Yang 1.1 or 1.0, the point is you're welcome to use new 1.0 features. It's far enough along the publication pipeline. So if you can simplify using sorry, I said 1.0, 1.1. If you can simplify your models by using Yang 1.1, do so. It's worth it. The Yang dockers are going to be looking for that. So if you're adding complexity so you don't, you're probably going to get caught up in the Yang docker reviews. So please start using 1.1. If you don't need 1.1, you can leave your documents at 1.0. I think I mean, if you want me to keep going, that's fine. I feel like I've gone over time.
Nope. 5 more minutes?
We have some extra time, but
We have 40 minutes.
Yeah, we've used the 40 minutes, so.
All right,
Yeah.
while they're thinking about whether I should talk on time.
So.
So one of the things that
So
happened.
5 more minutes.
Okay, one of the things that happen with the revised conceptual data stores is that it's possible to take a more fluid approach to where you put counters. So maybe you put your counters co-located with configuration information. This is one of those targets that's still moving. There's opportunity to do things that are more interesting, but at some point you have to ask, should you? And right now, I was hoping for the advice that just follow what was done in interfaces, where you separate out your counters into basically a very almost a top level branch. So you start out with interfaces, then immediately branch to configuration versus runtime information, which they call state. I'm not using the word state. They're runtime information, like counters. I was hoping for a simple direction like that. The consensus of the working group, though, is that sometimes that just adds too much complexity, and that there really is sometimes value of putting operational information right next to the configuration information. MTU might be a good example of this, where you want to be able to have what your MTU is configured at, and then what are you actually using. So configuration value auto, runtime 1500. You know, that's something you may be useful putting right there. And if you're doing that, add an extra leaf. So there's a section in the guidance to the Yang authors, I think it's 6087 bis, that goes into it, and it's basically make an informed choice. That's the guidance. That's a guidance from NetMod.
AC Lyndon, the thing that makes this a more compelling option now is if you have the applied state data store, the amount of pure operational state in addition to things that aren't just implied config could be very small. So should you really put those off in a separate tree?
Right. Yeah, there certainly is overhead of having a separate tree. Like, just think about your indexing overhead.
One concern with this, Cengiz Alaaddinoğlu.
If you're pointing to the specifics of the slide, I didn't write the slide.
No, I mean after where you have the state goes with the config as opposed to separate part of the tree. If I wanted that information pushed to me, now I have many places that I have to subscribe as opposed to the root of the operational portion of the tree.
Yeah, so if you're doing a telemetry application, there's different implications. If you're doing telemetry, though, you may have subscribed to something that'll give you both config information and operational information, but how often is your configuration information going to change, and do you really not care that it changes?
So it's going to push me just the changes, or it's going to push me to where I subscribe?
Well, if you're doing telemetry,
okay,
you'll only get changes. That's if you're doing gets, you're going to get the whole thing.
even if I subscribe at the, let's say, at the foobar's level, I'll only get the state.
Depends on whether you're running notifications.
Yeah.
If you're just running for notifications that are just going to give you changes, it'll only give you the leaf that changed.
Okay.
If you're retrieving the whole thing, it's going to give you both. So I think your point is still valid, but if you're only worried about the telemetry case of notification on changes, I think it's going to be the same.
Okay, that what you said describe works for me. That's fine. Thank you.
Okay. So the direction here, and it's in the 6087, and it's going to be cleaned up a little bit. The language is going to be tightened up a little there, but it's basically make an informed choice. So sometimes, you know, what's that great quote? You know, sometimes you really want to find this simple answer to a complex problem, but that simple answer is just wrong. So, oh, this is a good topic. This is an AD topic and a working group chair topic. Actually, well, I don't know who owns this. Ollie, you created it, but you sent it over to the working group, so I don't know who owns this. But should we continue doing this work?
Absolutely.
That's you know, our original objective was to get to a point where we had working group documents and to solve some major problems. And I think we've done that. We've achieved those major goals. There's some minor stuff with the conventions that we haven't achieved. So there's a question, should we continue? So the answer, yes, that you think we're doing good work. That's great feedback. We think that we might want to change the composition a little bit. We have a core group that's actively participating in our calls. And we think that the folks that don't really participate, we don't really have to have them on the design team. If you want to keep them on the design team, there's no cost. They don't show up. It doesn't matter. But we think some new blood and some new energy would be good. So from my standpoint, if you're interested in working on any of these topics, let the chairs, the AD, Aaliyah, let Aaliyah know, and we'll talk about, and also feel free to talk to me or any other design team member, and we'll go from there. If I've completely bored you, I apologize. Then don't volunteer.
Yeah, I think the design team has been doing really excellent work, and it's making a very big impact in this space, and I've heard similarly elsewhere. I agree that it's probably time to reformulate who's on the design team, and I would very much welcome volunteers who are excited about being seriously and significantly involved in the design team. And it's my design team because it's across the whole area. We're just reporting out here a lot.
It's no question it started as yours. I didn't mean to imply that it wasn't. I just didn't know what happened when you said, come here. So at that point.
Yeah, I didn't think you were confused. It's reporting out here because this gives a really good forum for the discussion of the results and
Great.
interactions.
All right. Thank you.
Thank you. Greg?
Okay, let's go. No, no.
It's PDF, right? Huh? Was it PDF?
Yeah, it was PDF. Okay, let's go next. Okay, so changes. We have a new member, Yuju. She joined us from NVO, this OEM design team, and Santosh. So he had a change in his situation that couldn't commit mount and had to step down. We appreciate his work. So what updates to existing documents? We have comments from Ron Bonica and Tal on requirements document, and Tal commented extensively on gap analysis. We appreciate that, their help. And we published 2 new documents, one on overlay OEM common header, and another is on OEM echo request reply. Next slide, please. So what are changed in the requirement document? Next. We extended the definition session to make clear what we understand by centralized controller, overlay nodes, network, and underlay network. Should note that in the document, there are underlay network and the transport network terms being used interchangeably. Next slide, please. Have added 2 requirements. One that OEM should provide mechanism to do MTU discovery, and that overlay OEM may support queries from the underlay and discovery of the transport topology mapping. Next. So in a passive, when we talk in a passive, and the question came in regard to definitions made in RFC 7799, which says that, well, which titled active passive performance measurement and in between. The definition given in RFC 7799 is very strict. Our interpretation of passive passive performance measurement tools and passive OEM in more general is that application of app measurement method does not change treatment of the data packet by the network. So that excludes method that add to the packet length, for example, because you can imagine that changing the packet length on the fly in the network would change their packet behavior and the network behavior as a result. What we mean is that, for example, their alternate marking method can be applied in a network in a way that is passive, so does not change the behavior of the network and treatment of packets. At the same time, yes, in some situations and in some encapsulations, the alternate marking method cannot be applied in this manner and probably would be considered as non-passive. It can be referred as a hybrid because it will be something in between of active and passive. Since active method is simply defined as a method when we inject special probes to do monitoring or performance measurement. Next slide, please. And we extended security consideration, just acknowledging that OEM does have substantial security consideration for protocols as existing and new, especially in overlay networks. If we are extending mechanism that we are being using, for example, in MPLS networks, because expectations of security level in MPLS domain may be somewhat different than in overlay network. Next slide, please. And so we extended and made changes to the gap analysis document. So we added conclusions section and we extended on the performance measurement section. Next, please. Again, we, for the active performance measurement, as was noted in earlier version, we consider two protocols is a two-way active measurement protocol, RFC 5357 and its extension, and MPLS loss delay measurement, RFC 6374. By looking into their functionality, so both are functionally very similar. The only difference is that 6374 offers more hardware-friendly format, and that probably resulted in our recommendation to use 6374 as a prototype for active performance measurement in overlay networks. Next slide, please. So now it's a new document. What we suggest is that when active OEM is being carried in overlay network, so the after overlay header immediately follows common OEM header. Next slide, please. Currently, it's defined as a 32-bit long field structured that containing the version number, message time to do the multiplexing, flags, and the length of their which reflects the number of octets of OEM message, including TLVs. Under consideration again, and that's where we would like to have your reviews and comments, whether the number of flags currently allocated, which might be too small for the future extensions, and thus it would be justifiable to add another 32 bits as a reserved field for future extensions to make them much more simpler in the future. Because, memory and bandwidth probably now is not that big concern. Next slide, please. As another option, what we thought is that timestamping might be useful and optionally used on OEM packets to measure. And we just put together a possible timestamp block that can be optionally appended to the common header, so thus making it much easier for the hardware to apply the timestamp, because it is very helpful when the timestamp can be applied by hardware, so to avoid unnecessary queuing in a host and make it timestamp inconsistent. Next slide. So overlay CCCV, it's sometimes referred as a ping, or I personally believe it's better to be characterized as request reply. Next slide, please. So those who spend time working with OSP ping will definitely recognize a lot of similarities with the format. The only thing is that we extracted the timestamp because really I don't know much that people are using timestamp to do delay measurement using OSP ping. But everything else is intact, so it allows to use it for some synthetic loss measurement. It has a session ID in name as a sender handle, the sequence number from the sender, and it allows you to define the return mode. It could be either and that's what we suggest as a default value over out-of-band IPv4, IPv6 network. At the same time as in OSP ping, it could be defined abundance of return channels, and there can be some of them could be in band if their layer is bidirectional. Next slide, please. So that captures pretty much what I already said. Next. So next steps would be is to continue work on extending functionality of echo request reply. And we've already been considering some applications in NVO3 and SFC. And we have a discussion with SFC, and I would like to make a note that when we talk about applicability of overlay OEM, it's to SFP OEM, because that, in our view, includes only SFFs, classifiers as SFFs. So there are OEM between SF and locally mapped service functions, so further end service functions, that is a local matter that SFP OEM can facilitate by collecting this information, by querying SFF. Okay. As always, the reviews, comments, greatly appreciated and welcome.
Hi, Greg. This is Soumya from Cisco. So I have a query.
Now I better understand blue.
Sure.
Now, get closer to the mic, please.
Soumya from Cisco. So I have a query regarding the OM operation set, which can be performed for a band of VNIs. So is that supported as part of the OM, overlay OM, a band of VNIs, same ping or any other OM operation, which can be carried in the same PDU, OM PDU, which applies to a set of VNIs rather than a single VNI?
Yeah, that's a very good question. So the question of the scope, again, that could be defined by, for example, the target TLV. Okay, so you define their, because, okay, if we talk about OEM domain, okay, so you can define the OEM domain in the TLV, which is a part of echo request. And that, again, one of the functions of echo request reply is to verify their correlation between your control plane and the data plane. Another is that you can do query of the state of the underlay for your given domain. And that would require solving another problem is that basically authorization. So whether you have a right to get this information because you are disclosing certain underlay topology information. Okay, but yes, I think that there could be TLVs that help you to express the group of targets that you are either verifying or querying about.
Sure. Since we have a separate header to define OEM PDU, can it be carried along with the data packet?
Okay, that, yes. We have examples of putting some OEM functionality on top of a data packet. It is possible to do it. We haven't thought about using this particular control packet for that purpose. And actually, it brings very good point, because how you indicate that along with their payload, with the data packet, you have certain OEM information. I think that that's where we need to discuss specific encapsulations in appropriate working group. But our thought was that it is through use of combination of the protocol field and what's in some encapsulations referenced as an OEM field.
Right.
Because then if we agree that combination of protocol field like IPv6 and set OEM flag indicates presence of additional OEM information which is appended to the packet. And then you have certain convention how you can parse this appendix, right? Because otherwise, how would you know that you have payload and you have OEM appendix? Okay, so you don't want to invent a new protocol type, but combination of the protocol type and OEM flag probably would be more definite indication of what you're doing.
And too much of metadata in the data flow if we carry OEM PDU?
Again, I think that's more of a question of encapsulation in a specific layer. So so we probably can continue it in NVO group and with SFC working group on a list, or all groups that are of interest together, including beer. Another thing is that, as was stated in many documents and realized by authors that proposed similar solutions, is that your ability to convey OEM information is limited by MTU. So then you will have to select to which packet you would like to append OEM information. Because if the packet is large by itself, it would not be much use to add more information, because you would not be able to gather information transcending many nodes.
That's right. But you have PMTUD as part of your...
we want, yes, actually, yes. And actually, it's a part of that discussion that we had, that basically with addition of underlay and overlay layers, encapsulations, there is a need to do path MTU discovery.
Yeah, that's my draft.
Yeah, and yeah, and actually, Yeah, that's how we came to recognize that, yes, that has to be explicit requirement.
Sure. Thanks, Ray.
Hi, Dave Dolson, Sendwine. The comment you just made about OAM following the data packet, it's the first I'd heard of it, at least from the SFC perspective. Is that something you want to support? That you think should be mentioned? I don't. If so, I guess it should be. I guess it should
okay,
make its way into the SFC.
Again,
base spec.
I think it's already a fact of a number of individual submissions proposing such solution. Okay, so if the working groups will decide that no, we would not allow that, okay, but currently these being proposed and discussed, so I cannot ignore them.
Where is that being discussed? Out of curiosity.
One of the proposal was inline OEM that been presented SFC and would be presented in NVO3. So they do piggyback on, okay, excuse me, I don't want to be degrading, but they do piggyback OEM on the data packet.
It will be presented in 10 minutes here.
Yeah. So, and it was presented SFC, and one of their applications is traversal proof, so basically which is to prove that you're traversing set of SFs.
Okay, thank you, Greg.
Okay, thank you.
QoS model.
Hi. This is Asim from Cisco. So I will talk about QoS Yang model. So let me give you a little background on this. You can go to the next slide. Okay. So we started working on it around 2 years back. We came up with a DIFSA specific model. And that was one vendor involved in that. So that particular model was based on RFC 3289, which is DIFSA MIB RFC. So the intention was that if it is based on a standard RFC, then maybe, a lot of vendors will be able to adopt directly. And then, it was in line based on that particular RFC. So when we publish it and when the other vendors joined it, vendors, people from Juniper, Huawei joined it, we figured out that there's a significant differences in the implementation of specifically between Cisco and Juniper. And so that time we thought that, okay, it has to be worked around. The point was that there were a lot of commonalities, like when we talk about QoS, excuse me. So the classification has to be there, the action has to be there, and something which attach or stitch these two, which is a policy, has to be there. And similarly, all these policy has to be applied to a target. So from the framework perspective, there are a lot of commonalities. And similarly, if we talk about the parameters, even parameters were very common or same or similar, I would say. So where was the challenge? The challenge was how the different vendors stitch these two together, these elements together. And that was a lot of differences. To give you one example for that, for example, one vendor was supporting hierarchical queuing, other was supporting multiple policy, one for the classification, one for the queuing. And so if the configuration comes through the Yang, it was not translating into corresponding configuration into the vendor model or vendor configuration model. And so we, to resolve that, we tried to split it into two-layer architecture, I would say. The first one was a framework, the framework of classification, framework of action, policy, and target. And
below that, we have a vendor-specific model where it cannot stitch together whatever in the framework will be stitching into the vendor-specific model. Also at the same time, there was a feedback from working group that this is DIFSR specific. What we want is a little more generic, little more QS specific. And we were pretty, excuse me, we were pretty sure that we wanted to focus on DIFSR. The reason being, this is well defined in IETF. And when we talk about QS in general, it becomes a too large a domain. And to define all the QS definitions or domains, technologies under single draft is virtually impossible. So what we
perhaps, did. Can I interrupt for 1 second? This is Chris, Chair. Just to give this a little context, when you're referring to feedback from the working group, that was the NetMod working group.
Yeah.
Right, and so maybe it would be, we forgot to put a little
absolutely.
context for this, this draft. Basically, this draft has been in NetMod for various iterations, have been in it for at least a year or more.
Right.
There's another QoS draft, Yang model, that's been, has a title Rtgwg. It hasn't been adopted. Basically, our plan is to move this draft from NetMod over to here, Rtgwg, and we'll reconcile it in whatever way it needs to be reconciled with the other draft. And I believe you're in conversation with those authors. Right. And so we're sort of resetting the stage for, okay, this work, we've decided this work should be done in Rtgwg. Mm-hmm. There's an existing draft that's gone through some history, but now we're addressing it here basically, and we're going to move forward and adopt some Rtgwg QoS model at some point.
Right, absolutely. So, I was coming to that later on, but thanks for pointing out. So there's another draft we plan to, work together. We already have started discussion on that. And as we understand currently, based on the discussion so far, the basic framework has to be common, and we already see that there will be little integrities of a particular implementation, which we have to take care. And so the point which I was trying to address, that a 3-layer architecture for the QoS model should be able to address any vendor-specific implementation. And so coming back to the comment which we got from NetMod working group was to define it a little more generic QoS framework. And that is what we focus on. We actually created a QoS framework of basic model, which include classification, action, policy, and target. And below that, earlier it was in the 2-layer architecture, DIFSR was part of the framework, but then we segregated DIFSR augmentation to the layer 2, where any particular technology like 802.1p or MPLS can be augmented to the basic QoS framework. And right now in the draft, we have given an example for DIFSR because we want to focus on DIFSR. But then, this particular draft can be adopted by any forum, or we can individually as part of IETF also, we can take the effort to augment further models to this particular framework. And any details which is very specific to the vendors, we have seen a lot of similarity in the DIFSR model, where we have a marking and we have a classification as part of the DIFSR, which is common across vendors. And so we have augmented that as part of the DIFSR specific model, which is layer 2 in this. But then there are a lot of integrities, like how do we define color aware meters versus, how do we have a different policies, like hierarchical QoS policy versus a queuing policy, which is separate from classification policy. So that stitching, little bit stitching can be done in the vendor-specific model. Okay. So based on all these parameters, based on all this understanding for the last 2 years, where we not only work with vendors, we actually talked to a lot of other vendors also, even though, they didn't join the effort in, coming up with a draft, but we have taken their input. We understand a lot of implementation details, and we think that this 3-layer model is the right way to implement. And maybe, we can still work further and get more inputs, but I think the framework should fit in for all the vendors. Currently, that is how we think. Okay, so based on that, we defined from a differ model, we created a QS draft, and we published a QS draft, which was presented last IETF in Argentina. So based on the further discussions, we have a little bit modified this draft, and this is 0.1 version. Actually, yeah, that is not 0.0, but 0.1. There's a little mistake over there. So in this version of the draft, earlier we had defined, based on 3289, we had defined a generic meter. Now we worked together with other vendors, and we figured out that maybe algorithmic based metering approach fits much better into vendors. So we already had defined a single rate tricolor meter and 2-rate tricolor meter as RFC 2697 and 2698. We were already supporting that, and we segregated out. We removed the base generic meter approach, and we added single rate 2-color meters to that. And that way, we have seen that that is how all the vendors implement anyway, and so that fits in much better way, rather than all the vendors we force them to implement something like generic meter. Other than that, there were some minor details. We always drop, nobody wanted to support as part of the queuing parameter. And target stats, again, we removed the stats for the generic meter from the target module. And as a reference to the model, we gave 2 examples how the different vendors can stitch together their model to this framework and create a complete model in itself. So we have already given 2 examples. In the last revision of the draft, we had given 1 example. Now we added 2nd example, which corresponding to 2 different implementations and how they can stitch together to create a complete model. Okay, so there are still some other issues we are working through, and some of them are like statistics issues, where different vendors have different statistics implementation. So we'll require some more feedback from young doctors and all to model it in such a way that if a particular vendor doesn't implement a particular statistics counter, and how do we, have a generic implementation which will display the counters and still, show something which is non-applicable. We show non-applicable rather than a value of 0, which will be wrong to show. And not only, counters across vendors, but within a single vendor, we have multiple devices. Some of the devices support particular statistics counters, some of the devices doesn't support. But in general, it is good to have those counters there, but then sometimes we don't support, then we have to indicate it is not applicable rather than show a value of 0, which will wrongly indicate that there's no counter update, even though it is not supported by a particular platform. So those intricacies we're working on. And then we're also working on, say, if we have to apply a policy on a target, and we have multiple policy of the same type. So whether we should support it or not. So a little bit of those intricacies. Also, we wanted to address most of the work as part of the basic framework, as part of the differ model. Right now, whatever we don't support, we have put under the vendor specific. Some of those, we require a little more discussion to see if we can push it little up and be a part of layer 2 of differ model rather than being a part of vendor specific model. Little more discussion will be required on those side, but that is pretty much it we are working on. So as a future direction, yes, so these are the open issues we have to work on. As the chair already told that There's already a draft recently which was published in the routing working group, and we are already in talk with the authors, and we have to integrate these two and basically show that how the common framework can be used by any vendor. So we don't have to have a different standard, different drafts, but we can integrate into a single draft where we can have a common framework and little specific vendor implementation go into the layer 3 of this architecture. We need to work through it. We already have a good starting point on that. We little bit already understand a lot of details about those models. We typically have a regular weekly meeting, so we'll invite the new into those discussions, and hopefully should be able to resolve positively by some, maybe possibly next IETF possibly. So also, I strongly recommend that people go through the draft, try to review it from a different, vendor's perspective, and provide any feedback if they have any. Any questions?
ASM. AC Lindum, Cisco Systems. I just looked at this again after a good 9 months since the last time I looked at it. And one thing I noticed, one thing I think you should add to it is, and see if you agree, since I have you up here, a terminology session, since different vendors may not have precise differences, especially for the basic functions, metering, whatever, just put in precisely what you need. It may be obvious to the people in the domain, but I've seen different people mean different things by those things. The other thing, right now, it's only configuration, right? You don't have any state at all. Do you intend to add state?
No, we have state as a state data. We have, as part of the target module, we have that.
The target,
Yeah,
okay.
as part of the target module.
I think now that it's broken up, it'd be good to describe that, better what each individual module, how they fit together.
Right.
Thanks.
Point taken. We actually, a lot of terminology we have taken from the RFC. To begin with, we have kind of, maintained that terminology so that it means the same thing for different vendors, as being some of those terms coming from MIB RFC 3289. But yeah, we can look into it and see if there is a particular, terminology gap or something which we have missed out. And I can, further talk to, AC to see, some of the terminology. We can gather more feedback on that and little bit modify wherever it is required. For description, we need to work a little bit on that direction, yes.
Chris Bowers. So when I didn't find this in the actual text, but you referred to layer 2 and layer 3 of your model. I assume you're talking about sort of your hierarchical part of your framework and not layer 2 Ethernet and layer 3 IP. I found that a little confusing at first because I first thought, wait, I didn't think you were defining layer 2 QoS. So I would just be careful not to let that get into the text, and it's
no, absolutely not.
So
I think that is gone.
Yeah, that's fine. That's just a clarification there.
Basically, to describe the model, I just use that layer architecture, but that layer is not L2 or L3 kind of,
right?
And it is not part of the draft anyway. We, may add little more details how that layer architecture will work, but reference as a layer 2 or layer 3 in that certainly will not be there. It is not there, it will not be there.
Yeah, I'm not sure whether this is working or not.
They're good enough.
Anyway, this is Himanshu Shah from Siena. One question I have is, is the diffserv TE part of the scope?
Diffserv key.
TE, yeah, diffserv TE, which introduces the class type. It adds another hierarchy with the class type on the diff serve.
I beg your pardon? Can you?
So there is also a diff serve TE, right? For MPLS.
Okay, for MPLS?
Yes. Traffic engineering, the diff serve TE traffic engineering.
Okay.
That has an impact on the class
Okay.
that you're doing. So
Okay.
it adds a class type. So that's another hierarchy.
Oh, the
that it adds.
TC in MPLS, you mean?
Yeah.
Okay. Yes. Okay. So far we have worked towards IP network as a multi-field classifier, as a behavioral aggregate in DiffServ. We haven't worked towards publishing anything related to MPLS TC kind of.
I think you misunderstood. He was talking about traffic engineering specifically. You're talking about experimental bits and MPLS header, correct?
Yes.
Okay. Yeah. So we haven't worked towards the MPLS QS model, which if you look into the architecture, it will fit in as something which is parallel to DiffServ here to represent what is there in the MPLS.
So I guess the question is, would the DiffServ TE be part of this scope, or it has to be pursued separately?
It should be part of the MPLS, I suppose.
So it would not be in this?
Not as part of. So basically we can define, and that is where we want to scope it, that we wanted to focus on very IP-centric DiffServ architecture as part of this draft. Additionally, creating a framework for QS, which can be adopted by other QS domain technology like MPLS, traffic engineering and all, or VPN, base 802.1p. So now we require a separate model which will augment, which will go parallel in DiffServ model in the complete architecture, but it will still use the common framework. I think that is very important, because once we adopt the common framework across vendors, we should be able to leverage that model across vendor. The reason being, overall QS, vendors have a similar implementation, even though they talk about this, they talk about MPLS or other things. So this framework will work across. That is more important, very important, I would say. But then those effort has to be part of a separate effort, will not be taken care as part of this draft.
So I think that should be something either with this working group or some other working group should.
Yeah, means yeah, absolutely. Means we're not sure whether it has to be taken into IETF or today morning we had a meeting with BBF for some of the implications if they can adopt this model, and we were strongly suggesting them that the common framework can be adopted, but certainly that requires some little more discussions on that. The one thing which they were worried about is that any augmentation they do, they cannot define a particular field as mandatory, which is something which is lacking the Yang, and nothing we can do from the architecture of the model itself. Something probably could be taken in next version of the Yang, but there is dependency where people can adopt this architecture for their corresponding QS domain implementations.
So a few comments. Traffic engineering is discussed in TS and should be there. With regards to liaison with other bodies, QS is of interest for everybody. So specifically BBF, I think you should be talking to them and look for alignment with what they're trying to do.
Okay.
They've been working on QS models as well.
Okay, absolutely.
Personal comment, hierarchical QS is not very well spelled and should be looked in better details. The multi-node structures.
Okay, Rtgwg is not well spelled, you mean?
Spelled out.
Spelled out, yes.
Spelled up.
So the relationship between different levels in nodes, and it's quite a complicated thing, but would be good because at the end you need to be able to represent it.
Okay. So when you say the layer architecture versus a hierarchical QoS, okay. So yeah, maybe we can add a little more text to that in the draft.
Would be great.
Okay, sure.
And welcome.
Okay, yeah, sure. Thank
Great to have you here.
you. Okay, thank you.
Frank? Yes, you're in charge. We are advanced.
All right, one more time on inbound OEM. I'm Frank, and this is work with a bunch of coworkers. All of them are listed up here. I'm giving you a brief overview of inbound OEM. There's 4 drafts out there. Very briefly on terminology, because, well, I don't even claim to get that right, which is why here's a little bit of the understanding of what we mean with inbound. Inbound for us is we do something that sits within the customer traffic, i.e. we modify the customer traffic to have additional fields as metadata in the customer traffic. We're not sending extra traffic, which is why I'm trying to differentiate that with what I call out of band, where you're sending additional traffic like you do with Ethernet CFM and the likes. And can we just do comments later on at the very end? And so I think that's a distinction that we're using here. If you follow things like what Al Morton has in his, what is that, 7799, you could refer to that principle as hybrid type 1. So it's somewhere between active and passive. So terminology-wise, well, anyway. Mental picture, the one thing is you're shooting something extra, which is what the police does, or it's even sending an extra car, which is an extra traffic, extra probe traffic. The other one is inbound, which is what we have in Germany, for instance, with these onboard units where every single truck or lorry is equipped with an onboard unit that monitors and records what the driver does all times, all day. That's what we're targeting. All right, so why is this useful? When we started off, and we started pretty much off in overlay scenarios, which is why what the earlier speaker said, well, yeah, these inbound OEM guys doing something that is very closely associated. We want to go do, and we would absolutely love to have, well, a frame format that we can put our metadata into. So that's good stuff. We started off in overlay and service chaining environments because what we found is if we have overlay VPNs, many people provision probes in overlay VPNs between all the PEs in order to make sure that a certain SLA is in place, so that you can do SLA checking in these overlay environments. Apparently, people are also smart that there is probes. So if you know that there's probe traffic, you can prioritize probe traffic. And a good indication is if you Google and look at what people do with this speed metering thing. And there is complaints that my speed meter or speedtest.com or whatever is going really fast, whereas my traffic's moving slow. Maybe there is prioritization going on for that particular traffic metering. And what I recently heard is that people meet or even beat the speed of light between Asia and the US when doing round-trip time measurements. There's something strange going on, right? So that's one area. The other area is you can use metadata in the packets to verify that a particular path was taken by a particular packet. So if you want traffic to go through a sequence of firewalls or a sequence of firewalls, web caches, what have you, and you want to make sure and prove in a cryptographically secure way that that happened, again, metadata in the packets is useful. Because if you want to verify every single packet, you need to verify every single packet. Other scenarios that we're all very well aware of is typical scenarios like you have heavy ECMP in your network. If you send ping and trace, that's obviously taken only one path, especially with IP. If you would monitor all the traffic at all times, you'd be getting an understanding of what traffic goes what way, right? And there is more crazy things that you can do by embedding additional information into the packets like GPS geolocation, you understand which path geographically a packet took, whether it traversed a particular country that you don't want the traffic to traverse, and the likes. So what do we want from a metadata perspective? Well, what additional data would we need to carry across to service these use cases? So in a nutshell, what really helps us if we could record node ID, ingress-egress interface information, information that helps us prove that a packet transited, which is a little bit of a cryptographic information there. Sequence numbering is useful if your protocol doesn't support sequence numbers in order to understand whether packets got reordered, dropped, or, well, even duplicated. Timestamps are useful if you want to go prove that certain delay bounds, jitter, and the likes, things are in place. And, well, custom metadata, anything you can dream of, up to GPS geolocation. By the way, if you define those things, let's define those things that we can define them in a dedicated namespace, so that we're not hooked up to the physical realities of the particular device or even the environment that we're working on. Because interfaces might be logical interfaces, interfaces might be physical interfaces, interfaces might even be tap points throughout a particular physical system. So you can trace and monitor, and that's apparently what we do today, traffic within a router or switch or what have you, between individual line cards and the likes, in order to, well, provide insights into the traffic scheduling within a system. Same goes for anything node ID, right? It doesn't necessarily need to be that we need one uniform way to go and address that, but it can be a namespace that is based on an operational domain. We want to go carry that data, and we need a place in the packet to carry that data. And there's two ways what we need to go and, well, take care of. One thing is, how do we transport the data? That's kind of the container format. And that container format will be something that is transport specific. And, well, I do believe that it's useful to define a common way to express that data, so that we have data formats identified and defined that work across multiple transports, which is why we have a transport draft, and which is mostly for informational purposes, to say, well, this is what we can do, and we have prototype implementations for some of those. And data formats, which we absolutely want to go specify, so that we have common formats and that we are transport independent on how we carry that information inbound across. And, well, you can carry that information across that we already talked about. In IPv6, you can use an extension header. That's what we do today. VXLAN GPE, you can use a protocol header, another one to do that. SRv6, you have, well, formerly you had policy elements, now you have full TLV structures. NSH type 2 does come with metadata and TLV formats, so relatively easy to drop in. And you can dream of additional things, like there's work going on for MPLS. There's work going on for even retrofitting the whole thing into IPv4. Yeah, so once we have this, we also should think of how we export that information right now, and the prototype information implementation that we have in FIDO, so VPP. We are spitting the whole thing out over IPFix, so NetFlow. But there might be other exports formats possible, and again, we use Kafka in another incarnation. How does that work? Just in a nutshell, and, well, that's the first time that the numbers render correctly. So, hey, yippee. So you have colors on your laptop, other people don't know. So packet arrives to a particular operational domain that we want to use inbound OEM in. We are not crazy enough to go and say, well, we want to go use that on the entire internet, but for a particular domain where you're in control of what really happens on your nodes, we believe that that's completely feasible and deployable today. So you enter the stuff, and what you do is you, well, put additional metadata in, and the metadata that you're putting in depends on your use case. If you want to verify the path, you might put proof of transit metadata in, and here in that particular case, we also want to trace the path. And in our particular case here, we want to trace the path from A to D, and we know that our domain diameter is maximum 3 hops, so we'll put an array in of 3 hops. So the packet size within the domain will be fixed. It's almost like slapping on a tunnel header, but it's obviously not a tunnel header. But we're not extending the packet hop by hop. We're not doing route recording as done in the past, where suddenly your path MTU becomes path dependent. So first hop would put in A and 1 as the outgoing link. Second hop would put C and 4 as the outgoing link. And now
6 would be the outgoing link, and we record B. So, and at the very end, you strip that information, you export it over IPFix, and you present the vanilla packet again. Yes, we're modifying the system slightly, which is why it's a little active. It's not entirely passive, but we're not sending extra packets, which is why it's not entirely active. So what information do we carry? We carry information that is typically per node scope, especially if we're doing trace kind of route recording style information, which is node ID, ingress interface, egress interface, timestamp. It's not necessary that all hops need to go and support that, but it's better if every hop would support it, because then you get full visibility. You have situations where you're only interested in a set of nodes. If you want to verify that a particular piece of traffic makes it across a firewall and maybe your cache, then you only want to go verify these 2 hops. You're not interested in intermediate nodes. So sometimes you're only interested in a set of nodes, and sometimes you're only interested in end-to-end or edge-to-edge, which is sequence numbering. So you only interested in whether the traffic makes it through or not, but well, that's the sequence numbering case. So how does it look? So we have data formats defined if you go through the drafts, which is basically an array, and within the array, you have a type definition that tells you what individual information goes into a particular entry of that array. And I'm just giving an example here where we're recording virtually everything, which is node ID, ingress, egress interface, timestamp, and generic data. Could be less if you're interested in less information, could be, well, more we haven't dreamt of so far. What we're doing is we're filling that thing pretty much like a stack bottoms up, because it has proven from hardware studies that is more efficient to do than kind of the other way around. Proof of transit, I'll briefly touch on that in the final 2 slides that I have. Basically requires us to carry 2 pieces of information. One piece of information is, if we're using Shamir secret sharing, by the way, a random number that is identifying a particular polynomial that is per packet, and a cumulative, which allows us to retrieve a secret in a cumulative way as we're computing it across a series of hops. And then we have sequence numbers. That's another edge option. So you can define those, and then you need to go and carry them. If you carry them, well, it's up to the transport that you're using. You can do that for v6, as I said. We have things defined for VXLAN GPE, segment routing, NSH, so those things are relatively straightforward. Briefly on proof of transit, what is the problem that we're trying to solve there? And it's been mentioned earlier on already. We're trying to answer the problem, the question that we typically don't ask ourselves. We're doing traffic engineering, segment routing, service chaining, whatever, and we believe that the traffic is following the path that we steer it, but nobody can prove it. In former times, you were able to prove it by checking the cabling, if you have physical gear. If you move to NFV, that's harder to prove, because a single vSwitch configuration can blow up the entire system. And especially the financial industry is particularly concerned about that particular fact, especially if they're moving to NFV. And Steve Ewell, one of the co-authors, brought that problem to the table around about 1.5 years, and we started working on that. And we came up with a schema that is computationally extremely lightweight, which is, again, something that he required. So what is the problem, and how do we solve the problem? What you want to go and get to is, if you have a system like this little diamond there, the upper path is the path to be verified, the lower path is the thing where things go nuts. We take a secret, and we split the secret here into 3 portions, and we dedicate a portion to every single node. And now as packets traverse through the network, we pick up a piece of that secret at every single hop, and then we can either reassemble the original secret or we can't. Here we can either reassemble the pie or we can't. If we can't reassemble the pie, something went wrong. I'm not telling you where things go wrong, but in typical situations, it's sufficient that something went wrong. Obviously, we're not kind of splitting up a pie in the network. We use something different, and the schema that we arrived at, yes, you can do this, by the way, with nested encryption or the likes, but that's relatively intense from a computational perspective. What we ended up using is Shamir secret sharing. And the main idea of Shamir secret sharing goes back to school math, where you remember a polynomial of degree n is defined by n plus 1 points. So line, 2 points, parabola, 3 points here, 3 points, and we take the polynomial as the secret. And now, given that a polynomial is uniquely identified by that set of points on the polynomial, we can use the individual points on the polynomial as shares of the secret. So for a polynomial of degree 2, 3 points will uniquely identify that particular polynomial. So if here we pick 3 points and we dedicate a point to every single hop, if we pick up these points, we will be able, using Lagrange interpolation, to reconstruct the polynomial, and that way we retrieve the secret. If we're not picking up all the points, we will never ever be able to retrieve that polynomial. So there is a lot of security and checks that have been done and proofs that have been done around Shamir secret sharing, so we can leverage all of those obviously, but that's the main idea. Operationalizing the idea, please go read the draft. We need a little bit more info, because otherwise with this schema, we would need to go and create a polynomial per packet, which is operationally very intense and not really feasible. That's pretty much it. So we have running code in Fido. You can go try it. We have a couple of demo videos out and see what it is looking like and how it works. And so the key question is that of interest to you guys in a routing area? We had a similar discussion in ops, and from my perspective, I don't really know where to land it the best, because it has a little bit of a flavor of routing, because OAM is also discussed here, but it also has a bit of an ops flavor, and so I'm not really sure where to land it best. But first, I would like to get feedback on the schema per se. Thank you.
Okay. Comments?
Yes, please. Go shoot.
Okay. Greg Mirsky Erickson. Can we go to their slide with police car?
Oops. I messed it up. You go best. So I stopped clicking, maybe. That's easier.
Yes. Okay, so this is very unconventional definition of out of band, because even though in IP, yes, in IPv4 v6, there is a challenge to do in-band OAM, understanding that in-band means that the packet traverses the same nodes and links and treated in the same way as QoS by as a data flow. In IPv4 and v6, that's a problem, because there is OEM does not recognize as the protocol. It has a different uses the different port numbers. But in Ethernet, actually, you're using this example as Ethernet CFM. Ethernet CFM does OEM in band, and that's recognized. And so MPLS OEM, if you're using GAL label, no, if you want to invent your terminology, of course, but conventional terminology says that CFM is in band OEM, and so using GAL label and entropy label in MPLS doesn't ensure you that you're in band. You can take a look at MPLS TP OEM, which was a requirement that you have in band OEM. Okay, next, please. So the
and
next,
that's a fair point, right? So I think terminology-wise, I'm, as I said early on, and did that in the opening statement, if somebody has better terminology, I'm all for that. I just want something that fits and is clean, and I struggle to find something that fits and is clean, which is why I use these mental examples, which is why I even use the pictures, right? So that we have an understanding of what we're trying to achieve, and then we can find the right terminology in a second step.
That terminology, choice of terminology, because you're implying that active OEM is inherently out of band, and then you assume that active OEM does not allow to achieve what you're trying to achieve. What I want to point is this is erroneous assumption, and you can use active OEM ensuring that this is following the same physical path as data packets, and then you can do everything verifying the traversal of the path, whether it's a physical entities or virtual entities, in the same way you do. And you can do it statistically sufficiently and not overload your data packets, because the problem with data packets, as you acknowledge, is that you're MTU limitation. So not everything can be appended or prepended to the data packet. Another comment is the saying that test packets can be sniffed. The T1 protocol designed specifically so you cannot sniff it. So the T1 measurements, latency, delay, and packet loss and out order delivery can be done absolutely unrecognizable to their third party. Okay? So if you're interested, we can discuss how.
Yeah, sure, absolutely. As I said,
Yeah,
so
but it's again,
I'm not
it's
hooked up to a particular.
Again, so there are methods already available that achieve what you're trying to achieve. Okay, so probably it's better to start with the problem statement, then we can discuss what can be done with available tools.
Which is why we have the requirements documents, and I don't believe, to your point, that you can do what we do with active OEM. Sending extra traffic is not an option, because we need to monitor the data packets of the customer, as opposed to you monitoring something that you're sending. But let's take that offline.
Okay, I can point to, again, example of OEM from the Sonnet SDH through the Ethernet, MPLS, and other technologies, and many, many other networks, including closed networks of the federal and
yeah, but if you go with that definition, so SDH OEM is in band.
And so MPLS and Ethernet is in band.
So BIP8 and the likes is all in band because it's traveling with a payload.
Right, and inherently CFM is in band.
It depends on how you define things. CFM sends extra packets.
Okay, again, industry defines it as in band. Okay,
So
you can disagree, but industry defines it.
Eric.
Eric Nordmark. This is interesting work. So one thing I'm trying to figure out is how do you sort of intend on using this, whether you are going to use it on a percentage of the traffic or basically turn this on all the traffic so you get lots of data and then you sample the data set that you get.
So both. And it depends on the deployment. So one use case is, yeah, you want to just verify a particular path or the likes, and then you're just classifying the traffic and you're saying, well, this is the only interesting piece of the traffic that I'm interested in, and I'm just going to go check on that. There might be the other way around, where you're interested in finding outliers or anomalies in the system. And that's an equal way where we say, well, we monitor all the traffic, and if you have, and we do that with BPP, we can easily get 6 million packets off a node, telemetry-wise. So we can spit out a load of data at multiple tens of gigs of the data of that particular node. And if I have that infrastructure in place, then why not monitor everything, spit it out, post-process it if you have the capacity, and well, do whatever you like with the data. I think it's really use case dependent, and we're not constraining things either way.
But there is an interesting question around the sort of measurement effect, right? Because if you run it all the time, right, it means that whatever size you're adding to the packets is constant. If you're saying that, no, I'm going to add ingress, I'm going to do this on 1% of the packets of this particular class. Well, now you're adding some jitter as well. It might be small, but so you're getting different measurements.
You're starting to impact the system, but if you're doing it for all traffic,
yes,
then, well, all traffic will be equally impacted. There's also another nuance to this whole thing, right? So we're basically having two implementations right now that are both in the quote-unquote fast path. That's not necessarily the case depending on how you do header processing, what ANCAP you're using, what transport you're using, what hardware underneath you're using, right? So there is an impact to that, and well, that's an operational consideration, as I said. So in certain cases, in many of the cases today, you're probably better off with just setting subset of the traffic. That's what I'm going to go monitor. But we've seen cases kind of that reverse the logic where you say, well, let's monitor everything, and we are dropping the things that we're not interested in on the ground later on in order to find anomalies in the system and outliers.
Okay.
Thank you.
John Messenger. It seems to me that if you...
Can you speak up a little?
Yes.
The audio in this room is a little odd for me. Thank you.
In the use case where you only monitor some of the traffic, I think that makes it somewhat akin to your definition of out of band. I think it only matches your definition of in-band if you actually monitor all the traffic.
You can argue that point.
Yes, just an observation.
No, yeah,
I
agree.
also would strongly recommend that you find another term.
Give me one, please.
Well, the only one that came to mind, and I'm not sure that it's acceptable, would be something like piggyback OAM.
Yeah, why not?
Because that
sounds a
gives you
little too childish, too Pokemon, but yeah.
Yeah, I mean, and so I think when you're thinking about those terms, what you've got to try to think about is the purpose of what you're trying to achieve, and so that can be slightly complicated by the different use cases. So it does require some thought, but it's definitely the case that a good number of people are pretty upset about the use of the word.
Oh yeah, I noticed that already.
And there was, I also have one other point, which isn't a criticism, it's a question. Have you considered the privacy implications of pervasive monitoring of packets?
We had that as a topic. We constrain things to a single operational domain for that one purpose. So we assume that pervasive monitoring is okay where you do it. But yes, well, anything that you add from a metadata perspective could be subject to privacy concerns. So the more info we gather, the more concerns there are. Yes.
Okay. So I think that's a big topic and
Oh,
needs
yeah.
to be discussed.
Absolutely.
So
we want to go create value that helps us from an operational perspective. It can be misused. Absolutely.
Yes. The other thing, you did make a comment that when you monitor all traffic is equally impacted. I think there is a difference between the effect of this technique on data which consists primarily of small packets and data that consists of large packets because of the scale of the overhead compared with the size of the data.
Yeah, but I tend to compare that to tunneling. We do tunneling all across. We don't care too much, and we don't think too heavily if we start to do tunneling, GRE tunneling or what that likes. And performance-wise, if we look at things today on a router of ours, Cisco, then we are pretty much on par from a performance or CPU additional consumption perspective with what GRE does. Are people too concerned about GRE? And whether they use it or not, whether it's been used in the network somewhere? Do people spend a lot of cycles on whether they're using an additional tunnel there? Yeah, sometimes not. But we're kind of on par with that from an overall kind of additional effort perspective. John.
So, practical question. So I can fully see how we can do it on Intel NVP-like architecture where instantiate this function as additional node in the graph. Potentially, I could see how we could do it on high-end NPU. How about fixed pipeline, something like chip Broadcom? Have you looked into implications, performance degradation?
I didn't really fully get that because, again, the audio is a little odd here.
So implication of doing this on low-end fixed pipeline gear?
So not in detail. But one reason why we did things like, or why we moved away from doing things like nested encryption for proof of transit is, yeah, you can't necessarily assume that you have an AES feature set in your CPU available. So that's why we moved to something cheaper and simpler. Have we done a detailed evaluation on ARM? Not yet.
It would be really good if you elaborate a bit in the draft where the limitation. So when people start implementing, they know they're not going to hit.
No, I think that there's also something that came up in another working group. We will publish, as part of FIDO, CISA test results on the performance application on VPP, and they're ponying up a lab for ARM in FIDO. So we will get those numbers, hopefully, in the not too far future as well. So maybe at next slide here.
Thank you.
Thank you. So would you mind doing something like a hum on whether it's interesting to people in routing?
So another head. We'll talk to our AD and come back with an answer.
Because Aliyah just disappeared prior to the presentation. That's the.
Probably not intentionally.
Well, I take that personally, you know that.
Oh, don't. So,
all right, guys.
We will come back on this and notify you whether I think it's interesting work, it's definitely value.
Okay.
We'll discuss with this.
Thank you.
Thank you.
Thanks.
Just another reminder about blue sheets.
Anyone? Blue sheets?
Yeah, just.
And we are early for the lunch. Thank you, everybody, and see you in Korea.